For millennia, humanity has gazed at the stars. The night sky, a canvas of twinkling lights, has always been a source of wonder and inspiration. From ancient civilizations to modern societies, the stars have guided us, inspired myths, and sparked our imagination. They have been our constant companions, silently watching over us as we evolved and grew. We pondered our place in the universe. Are we alone in this vast expanse? What lies beyond the reach of our eyes? These questions have driven philosophers, scientists, and dreamers alike to seek answers. The night sky, with its infinite mysteries, has always been a reminder of how small we are and how much there is yet to discover. We dreamed of reaching out and touching the cosmos. Our ancestors imagined gods and heroes among the stars, while modern dreamers envisioned spacecraft and interstellar travel. The idea of exploring the unknown, of venturing into the great beyond, has always been a part of the human spirit. It's a dream that has persisted through the ages, evolving with our understanding of the universe. Today, that dream feels closer than ever. With advancements in technology, what once seemed like science fiction is now becoming a reality. Space agencies and private companies are working tirelessly to make space travel accessible. The International Space Station orbits our planet, a testament to human ingenuity and cooperation. We are on the brink of a new era in space exploration. Imagine leaving Earth behind, venturing beyond our solar system. Picture yourself aboard a spacecraft, watching as our blue planet becomes a distant dot in the vastness of space. The journey would be long and challenging, but the rewards would be immeasurable. To see new worlds, to experience the unknown, to be a part of something greater than ourselves. Picture yourself on a journey to a distant star system, a place where two suns illuminate the sky. The sight would be breathtaking, a reminder of the beauty and diversity of the universe. Each star system holds its own secrets, its own wonders waiting to be discovered. The possibilities are endless, limited only by our imagination and determination. This is the future of space exploration, a future we are striving to create. It's a future where humanity is not confined to one planet, but is a spacefaring civilization. A future where we explore, learn, and grow beyond the boundaries of our homeworld. The path to this future is paved with innovation, collaboration, and a relentless pursuit of knowledge. The journey begins with a single step, a leap of faith into the unknown. Each mission, each discovery, brings us closer to realizing our dreams. The first steps on a new planet, the launch of a new spacecraft, these are milestones in our journey. They are symbols of our courage and our commitment to exploring the cosmos. It is a journey fueled by curiosity, by the insatiable human desire to explore. Scientists and engineers work tirelessly to push the boundaries of what is possible. Astronauts train rigorously to prepare for the challenges of space travel. Space enthusiasts and dreamers keep the spirit of exploration alive, inspiring the next generation to reach for the stars. The vast distances between stars might seem daunting. The challenges of interstellar travel are immense, from the technical hurdles to the physical and psychological demands on astronauts. But these challenges are not insurmountable. With each passing day, we make progress, finding new solutions and overcoming obstacles. But the spirit of discovery burns brighter. The desire to explore, to understand, to push beyond our limits is a fundamental part of who we are. It's what drives us to look up at the night sky and wonder. It's what motivates us to build rockets, to send probes to distant planets, to dream of what lies beyond. We are explorers at heart, driven by a thirst for knowledge and a yearning to unravel the mysteries of the universe. Each new discovery, each new piece of the puzzle brings us closer to understanding our place in the cosmos. The journey is long and challenging, but the rewards are beyond measure. Together, we will reach for the stars and make our distant dreams a reality. Our journey to the stars has already begun. We have sent probes to the outer reaches of our solar system. We have landed rovers on Mars. The Parker Solar Probe, a testament to human ingenuity, has touched the sun. It has braved the intense heat and radiation of our star. These achievements demonstrate our growing capabilities. They are stepping stones on our path to interstellar travel. But to reach a distant star system within a human lifetime, we need a radical shift in technology. We need to think bigger, bolder, and push the boundaries of what we believe is possible. Enter Breakthrough Starshot, an ambitious project aiming to send a spacecraft to Alpha Centauri. This is our closest neighboring star system. The plan is audacious. Propel a tiny gram-scale spacecraft at 20% the speed of light. To do this, we will use powerful lasers here on Earth. This technology, while still in its early stages, holds immense promise. Imagine reaching Alpha Centauri, not in thousands of years, but in decades. This opens up a realm of possibilities. It allows us to explore new worlds and study distant stars in unprecedented detail. Section 4. Aboard the Starship, a front row seat to the cosmos. Imagine yourself aboard a starship of the future, a vessel capable of traveling at a fraction of the speed of light. This isn't just any ordinary journey, it's a voyage that transcends the boundaries of human experience and imagination. As you accelerate away from Earth, our planet shrinks behind you, becoming a pale blue dot in the vast expanse of space. The familiar landscapes and oceans fade into the background, replaced by the infinite blackness of the cosmos. The journey would be unlike anything imaginable. You would witness celestial phenomena that have only been theorized by scientists and dreamt of by visionaries. The beauty and mystery of the universe would unfold before your very eyes. Days turn into weeks, weeks into months, and months into years. The passage of time becomes a fluid concept, almost irrelevant in the grand scheme of your voyage. Each moment is filled with awe and wonder as you traverse the cosmos. The universe unfolds before your eyes, a breathtaking tapestry of stars, nebulae, and galaxies. Each celestial body tells a story, a chapter in the grand narrative of the cosmos. The colors and patterns are more vivid and intricate than any artist could ever capture. Time itself takes on a different meaning as you travel at incredible speeds. The theory of relativity becomes a lived experience, with time dilation making your journey feel both fleeting and eternal. You are a time traveler, racing towards a future among the stars. Each second brings you closer to new worlds, new discoveries, and new possibilities. The universe is your playground, and the stars are your companions on this incredible journey. As you pass by distant planets, you can't help but wonder about the mysteries they hold. Are there other forms of life out there? What secrets do these alien worlds keep? Each planet is a new frontier, a new opportunity for exploration and understanding. Imagine the thrill of entering a wormhole, a shortcut through space-time that could take you to the farthest reaches of the universe in an instant. The very fabric of reality bends and twists, creating a surreal and exhilarating experience. Emerging from the wormhole, you find yourself in a completely different part of the universe. A new galaxy comes into view, filled with stars and planets that have never been seen by human eyes. The sense of discovery is overwhelming. Approaching a binary star system, you witness the dance of two stars orbiting each other. Their gravitational pull creates a mesmerizing ballet of light and energy, a cosmic performance that has been ongoing for millions of years. Finally, you land on an alien moon, stepping onto its surface for the first time. The landscape is both familiar and alien, a testament to the endless diversity of the universe. Each step you take is a step into the unknown, a new chapter in the story of human exploration. Planting a flag on this distant moon, you look back at your spaceship, a symbol of human ingenuity and the unquenchable thirst for knowledge. The journey has been long and arduous, but the rewards are beyond measure. As your spaceship takes off from the moon and heads towards the stars once more, you realize that this is just the beginning. The universe is vast and full of wonders, and your journey is far from over. The cosmos awaits, and you have a front row seat to its endless marvels. Section 5. Binary Stars, Unveiling Cosmic Mysteries. Your destination, a binary star system, a place where two suns grace the sky. These systems, once thought to be rare, are now known to be quite common. They offer a unique opportunity to study the dynamics of stellar evolution. Imagine the discoveries that await planets bathed in the light of two suns. Exotic life forms adapted to these unique conditions. Studying binary star systems could revolutionize our understanding of planetary formation. It could shed light on the conditions necessary for life to arise in the universe. Section 6. The Challenges Ahead, Conquering the Cosmos. The journey to a binary star system is not without its challenges. The distances are vast, the technological hurdles immense, the dangers are ever present. We must develop new propulsion systems, shielding to protect spacecraft from interstellar radiation, and life support systems capable of sustaining humans for decades-long journeys. Beyond the technological challenges, there are human challenges to overcome. How do we prepare humans for the psychological and physiological demands of interstellar travel? How do we ensure the health and well-being of generations born among the stars? Section 7. A Future Among the Stars. humanity's next chapter. As we stand on the precipice of a new era, the dream of exploring the vast expanse of space is no longer confined to the realms of science fiction. It is becoming our reality, a testament to human curiosity and determination. Despite these challenges, the dream of reaching a binary star system is within our grasp. The binary star system, with its two suns dancing in a cosmic ballet, represents the next frontier in our quest for knowledge. It is a symbol of the boundless possibilities that lie ahead. With each passing year, we make strides in our understanding of the universe and our technological capabilities. Our scientists and engineers are pushing the boundaries of what is possible, developing new technologies that will enable us to travel further and faster than ever before. Telescopes and observatories are peering deeper into the cosmos, revealing secrets that have been hidden for eons. We are laying the groundwork for a future where humanity can explore the cosmos. The construction of advanced spacecraft and the establishment of space colonies are no longer distant dreams but tangible goals. These endeavors are the stepping stones to a future where humans can live and thrive beyond Earth. The journey to the stars is a relay race. Each mission, each discovery, is a baton passed from one generation to the next. It is a collective effort that spans decades, even centuries, with each generation building upon the achievements of those who came before. Each generation passes the baton to the next, building upon the knowledge and achievements of those who came before. The pioneers of space exploration, from the early days of rocketry to the moon landings, have paved the way for today's scientists and engineers. Their legacy is a foundation upon which we continue to build. It is a journey that will inspire generations to come. The sight of children gazing up at the stars, dreaming of what lies beyond, is a powerful reminder of the enduring human spirit. In classrooms around the world, the next generation of explorers is being inspired to reach for the stars. It will push the boundaries of human ingenuity and forever alter our place in the cosmos. The innovations in space technology are not just about reaching new destinations. They are about redefining what it means to be human. As we achieve new milestones in space exploration, we are not just expanding our physical horizons, but also our understanding of our place in the universe. This is humanity's next chapter, a story of exploration, innovation. Stars are within our reach, and the future is ours to shape. To understand the magnitude of this endeavor, we must first understand what a binary star system is. Simply put, it is a system where two stars orbit around their common center of mass. These celestial dances are more common than you might think. In fact, Alpha Centauri, our closest stellar neighbor, is a triple star system. Imagine a sky illuminated by two suns, casting an ethereal glow on the alien landscape below. This is the reality of a binary star system. The planets within these systems orbit around both stars, creating complex and fascinating gravitational interactions. These systems offer unique opportunities and challenges for space exploration. The presence of two stars can create habitable zones different from our own, potentially harboring life as we know it or even more exotic forms. However, the gravitational dynamics of these systems also make space travel and planetary colonization significantly more complex. The most daunting obstacle to reaching a binary star system is the sheer vastness of space. The distances involved are almost incomprehensible to the human mind. When we look up at the night sky, the stars seem so close, almost within our grasp. But in reality, they are separated by unfathomable distances. Even the closest star systems are several light years away. For instance, Proxima Centauri, the nearest star to our solar system, is about 4.24 light years away. This might not sound like much, but in terms of space travel, it's an enormous distance. To put that into perspective, light, traveling at an astounding 300,000 kilometers per second, takes years to reach us from these systems. Light from Proxima Centauri, for example, takes over 4 years to get to Earth. This speed is the ultimate speed limit in the universe, and yet, even at this incredible velocity, the journey is long. Traditional propulsion systems, like the chemical rockets we use today, are simply not efficient enough for interstellar travel. These rockets have served us well for journeys within our solar system, but they fall short when it comes to the vast distances between stars. These rockets rely on burning fuel to create thrust, which limits their range and speed. The amount of fuel required for a journey to even the nearest star would be impractical, if not impossible, to carry. Even with the most powerful rockets imaginable, a journey to the nearest star system would take tens of thousands of years. This is far beyond a human lifetime, making such missions unfeasible with our current technology. This is where the need for revolutionary propulsion technologies becomes apparent. We must look beyond conventional methods and explore new, innovative ways to travel through space. We need to find ways to propel spacecraft at a significant fraction of the speed of light to make interstellar travel a reality within a human lifetime. Concepts such as ion drives, nuclear propulsion, and even theoretical ideas like warp drives and wormholes are being explored. This is not just a matter of building faster rockets, but of rethinking the very principles of space travel. We need to harness new forms of energy and propulsion that can sustain long-duration missions and achieve the high speeds necessary for interstellar voyages. The challenge is immense, but so is the potential reward. The dream of reaching other star systems and perhaps even discovering new forms of life or habitable planets drives us to push the boundaries of what is possible. The journey to the stars is the next great adventure for humanity, and it begins with overcoming the challenge of interstellar travel. Section 4. Technological leaps and bounds. The good news is that scientists and engineers around the world are already working on these next-generation propulsion systems. These systems are not just theoretical. They are being actively researched and developed in cutting-edge laboratories and facilities. The collaboration between international space agencies, private companies, and academic institutions is driving innovation at an unprecedented pace. One promising concept is nuclear fusion propulsion. Unlike traditional chemical rockets, which rely on burning fuel to create thrust, nuclear fusion propulsion aims to harness the power of the stars themselves. By fusing atomic nuclei, this technology could generate immense amounts of energy, far surpassing what is possible with current propulsion methods. This technology harnesses the immense energy released by fusing atoms, potentially allowing us to achieve speeds unimaginable with current technology. The process involves creating conditions similar to those found in the core of stars, where temperatures and pressures are so high that atomic nuclei can overcome their natural repulsion and fuse together. The energy released in this process is what powers the sun and other stars, and if we can replicate it on a spacecraft, the possibilities are staggering. Another intriguing possibility is the solar sail. Unlike traditional propulsion systems, solar sails do not require fuel. Instead, they rely on the pressure exerted by photons from the sun. These large, reflective sails would be propelled by the pressure of sunlight, gradually accelerating over time. These large, reflective sails would be propelled by the pressure of sunlight. The concept is simple yet revolutionary. As photons from the sun strike the sail, they transfer momentum to the spacecraft, pushing it forward. Over long periods, this gentle but continuous push could accelerate the spacecraft to significant speeds. While it would take a long time to accelerate, a solar sail could eventually reach a significant fraction of the speed of light, making interstellar travel a real possibility. The key advantage of solar sails is their ability to continue accelerating as long as they are exposed to sunlight, unlike traditional rockets that burn through their fuel quickly. But reaching a distant star system is only half the battle. Once we arrive, we face the challenge of exploring and potentially colonizing these new worlds. The distances involved are so vast that any mission would likely take decades, if not centuries, to complete. We also need to develop technologies that will allow us to survive and thrive in these alien environments. This means creating habitats that can protect us from harsh conditions, finding ways to produce food and water, and ensuring that we can maintain our health far from Earth. This includes advanced terraforming techniques to make planets habitable. Terraforming involves altering the environment of a planet to make it more Earth-like, potentially allowing humans to live there without the need for spacesuits or enclosed habitats. This could involve releasing greenhouse gases to warm the planet, introducing microorganisms to create a breathable atmosphere, and even importing water from other celestial bodies, as well as self-sustaining space habitats that can provide all the necessities for human life. These habitats would need to be completely self-sufficient, capable of recycling air, water, and waste, and producing food through advanced agricultural techniques. The goal is to create a closed-loop system where nothing is wasted and everything is reused, ensuring the long-term survival of human colonies in space. Section 5. The human element. However, the challenges of building a home in a binary star system go beyond the purely technological. We must also consider the psychological and societal implications of such an endeavor. How will humans adapt to life on a generation ship, spending decades or even centuries in transit? The psychological impact of long-duration space travel is a significant concern. Isolation, confinement, and the lack of familiar environmental cues can all take a toll on mental well-being. We need to develop strategies for maintaining mental health during these long voyages, such as creating stimulating environments and providing psychological support. Moreover, the social dynamics of a spacefaring society will be vastly different from those on Earth. We will need to establish new forms of governance, resource allocation, and conflict resolution to ensure the success and sustainability. Imagine gazing up at a sky unlike our own. Instead of a single sun, imagine two suns, locked in a celestial dance, casting their light across the heavens. This is the reality for countless star systems across the cosmos, systems where planets may harbor life, thriving under the warmth of twin suns. These binary star systems, as we call them, offer tantalizing possibilities for the future of humanity, a future that might extend beyond our solar system, into realms we have only begun to imagine. Our journey to understand these distant realms begins with appreciating the sheer scale of the universe, a universe so vast that it defies comprehension. It's a vast expanse filled with billions upon billions of stars, each one a potential beacon of discovery. And within this vastness, binary star systems are not the exception. They are the rule, a common feature in the cosmic landscape. This realization sparks a fundamental question. Could we one day reach these distant shores and explore the mysteries they hold? Could we as a species journey to a world lit by two suns and witness the dawn of a new era in human exploration? The answer, while complex, is not outside the realm of possibility. It requires a leap of faith and a commitment to pushing the boundaries of what we know. It hinges on our ingenuity, our determination, and our enduring fascination with the cosmos, driving us to innovate and explore. The journey will be long, fraught with challenges, but the potential rewards are immeasurable, promising a future where humanity reaches for the stars and beyond. Our story begins not in some distant future, but right here, right now. We are living in an era of unprecedented advancement in space exploration. Companies like SpaceX, with their reusable rockets, are driving down the cost of space travel. This paves the way for more frequent and ambitious missions. Meanwhile, NASA's Artemis program aims to establish a sustained presence on the Moon. This is a crucial stepping stone for future missions further into our solar system. These endeavors are not mere feats of engineering, they are testaments to the human spirit of exploration. They demonstrate our unwavering desire to push the boundaries of what's possible. Each successful launch, each new discovery brings us closer to unraveling the mysteries of the universe. And perhaps, just perhaps, it brings us closer to answering that age-old question, are we alone? To comprehend the allure of binary star systems, we must first understand what they are. Simply put, a binary star system consists of two stars that orbit a common center of mass. This cosmic dance can create breathtaking celestial displays, with the stars eclipsing each other or casting intricate shadows on nearby planets. The significance of binary star systems goes beyond their beauty. They are, in many ways, ideal laboratories for studying stellar evolution. The gravitational interplay between the two stars offers insights into their formation, their life cycles, and their ultimate fate. Moreover, recent discoveries suggest that planets can form and exist within these systems. Some of these planets, known as circumbinary planets, orbit both stars. Others orbit a single star in the system, experiencing the gravitational pull of both. This diversity of planetary environments within binary systems opens up a realm of possibilities for life to emerge and evolve. The immense distances between stars present a formidable challenge for interstellar travel. Even at the speed of light, a journey to the nearest star system, Alpha Centauri, would take over 4 years. To overcome this hurdle, we need revolutionary advancements in propulsion systems. One promising concept is fusion propulsion, which harnesses the immense energy released by fusing atoms. This technology could theoretically propel spacecraft to a significant fraction of the speed of light, dramatically reducing travel times. Another intriguing avenue is the development of warp drive technology, a concept that has long captivated science fiction enthusiasts. While still highly speculative, warp drive technology explores the possibility of distorting spacetime itself to achieve faster-than-light travel. While these technologies may seem like the stuff of science fiction, they are grounded in real scientific principles. And while significant hurdles remain, the pursuit of interstellar travel is no longer a pipe dream. It is a challenge that we, as a species, are actively working towards. The journey to a binary star system will be more than just a technological feat. It will be a monumental test of human resilience and adaptability. It will challenge our ability to work together, adapt to new environments, and overcome unforeseen obstacles. Confined within a spacecraft for decades, if not centuries, future interstellar travelers will face a unique set of challenges that will test their endurance and ingenuity. One of the primary concerns is the need for a self-sustaining life support system that can function independently for extended periods. This system would need to recycle air efficiently, purify water, and manage waste effectively, creating a closed-loop ecological system within the confines of the spacecraft to ensure sustainability. The psychological effects of long-term space travel are another significant concern. Isolation, confinement, and the lack of familiar terrestrial cues could pose significant challenges to the mental well-being of the crew. The absence of earthly landscapes and social interactions could lead to feelings of loneliness and depression. Addressing these challenges will require not just technological innovation, but also a deep understanding of human biology and psychology. We must explore new ways to support mental health in space. We will need to develop new methods for maintaining physical and mental health in the extreme environment of space, including regular exercise and mental health support systems. The success of future interstellar missions will depend not just on our ability to reach the stars, but also on our ability to thrive once we get there. Establishing a thriving colony in deep space will be the ultimate testament to human ingenuity, perseverance, and the unyielding spirit of exploration. Section 6. New homes among the stars, habitable planets in binary systems. The ultimate goal of interstellar travel is not just to visit other star systems, but to find new homes for humanity. This quest drives our exploration and fuels our imagination, pushing the boundaries of what we believe is possible. Binary star systems, with their diverse range of planetary environments, offer intriguing possibilities. These systems, where two stars orbit each other, create unique gravitational dynamics that can lead to the formation of planets with varied and fascinating characteristics. Planets within the habitable zone of a binary star, the region where temperatures allow for liquid water, could potentially harbor life. This habitable zone is crucial because liquid water is essential for life as we know it, making these planets prime candidates for exploration. These planets might be tidally locked, with one side always facing their star, resulting in extreme temperature differences between the day and night sides. This could create harsh environments, but also unique ecosystems that adapt to these conditions. Or they might orbit both stars in a stable configuration, experiencing two sunrises and two sunsets each day. Such a planet would have a dynamic and ever-changing sky, offering a spectacular view and a unique climate. The discovery of such planets would be a profound moment in human history. It would expand our understanding of the universe and our place within it, opening new frontiers for science and exploration. It would suggest that our planet is not unique, that life may exist in countless forms throughout the universe. This realization would challenge our perceptions and inspire us to seek out these new forms of life. And it would fuel our desire to reach out, to explore, and perhaps one day, to make these distant worlds our new homes. The dream of interstellar colonization would become a tangible goal, driving humanity to new heights of innovation and discovery. Section 7. The Unfolding Tapestry, a vision of humanity's future. Looking ahead, the future of space exploration is brimming with possibilities. Imagine a future where humanity becomes a multi-planetary species with colonies on Mars, the Moon, and perhaps even beyond. Imagine giant space telescopes capable of peering into the atmospheres of exoplanets, searching for signs of life. Envision spacecraft powered by fusion engines, embarking on multi-generational voyages to distant star systems. This future is not guaranteed, but it is within our reach. It will require continued investment in science and technology, international collaboration, and an unwavering commitment to exploration. But the rewards, both scientific and philosophical, make the journey worthwhile. Section 8. The drive to explore, an essential human trait. The desire to explore is woven into the fabric of our being. From the earliest humans who ventured out of Africa to the intrepid explorers who charted our planet, we have always sought to push the boundaries of the known world. This drive to explore is not merely a thirst for adventure, although that is certainly part of it. It is also a quest for knowledge, a desire to understand our place in the cosmos. By venturing into the unknown, we challenge our assumptions, expand our horizons, and gain a deeper appreciation for the wonders of the universe. And in doing so, we often make unexpected discoveries that benefit humanity in unforeseen ways. From the technologies that emerge from space exploration to the inspiration it sparks in generations of scientists and engineers, the pursuit of the cosmos yields tangible rewards here on Earth. Section 9. Our Destiny Among the Stars. The journey to a binary star system and the challenges it presents may seem daunting, but it is a journey we are destined to undertake. For in the grand tapestry of the cosmos, we are but a single thread connected to every other star, every other planet by the fabric of space-time itself. Our destiny lies not just in exploring the universe but in understanding it, in unraveling its mysteries and embracing its infinite possibilities. And perhaps, just perhaps, in finding other beings who share our sense of wonder and our desire to explore the cosmos. The journey will be long and the path ahead may be uncertain, but one thing is clear: the future of humanity, but just the beginning. Today's space technology, while impressive, remains insufficient for true interstellar travel. Chemical rockets, our current workhorses, are simply too slow for the vast distances involved. Reaching even the closest star system, Alpha Centauri, would take tens of thousands of years with current technology. However, the future of space travel lies in advanced propulsion systems. Fusion propulsion, mimicking the energy production of stars, could propel spacecraft at a significant fraction of the speed of light. Solar sails, massive sails pushed by the pressure of sunlight, offer another promising avenue. By 2250, these technologies, along with advancements in artificial intelligence, robotics, and closed-loop life support systems, could make interstellar travel a reality. The journey will demand groundbreaking innovation and unwavering dedication, but the potential rewards are simply too great to ignore. Binary star systems, unlike our own solar system, consist of two stars orbiting a common center of mass. These stellar pairs come in various configurations, with some stars orbiting each other closely, while others are separated by vast distances. This unique celestial dance creates environments vastly different from our own. Planets in binary star systems experience the gravitational pull of two suns, resulting in complex and often unstable orbits. The amount of light and heat these planets receive can fluctuate dramatically, leading to extreme seasonal variations. Life on such planets, if it exists, would have to adapt to these challenging conditions. Section 4. The Interstellar Voyage, a technological tightrope walk. The journey to a binary star system presents formidable technological hurdles. These challenges are not just about the vast distances involved, but also about the myriad of technical and human factors that must be addressed to ensure a successful mission. The binary star system, with its two suns, offers a unique and complex environment that requires advanced navigation and propulsion systems. The distances involved are staggering, measured in light years, meaning it takes years for light itself to travel between these stars. To put this into perspective, 1 light year is approximately 5.88 trillion miles. The closest star system to our own, Alpha Centauri, is about 4.37 light years away. Traveling such distances requires not only advanced propulsion technology, but also a deep understanding of the interstellar medium and the potential hazards it presents. Even traveling at a significant fraction of the speed of light, the journey would take many human lifetimes. For instance, if we could travel at 10% of the speed of light, it would still take over 40 years to reach Alpha Centauri. This means that the mission would span multiple generations, requiring a sustainable and self-sufficient environment for the crew. Shielding the spacecraft and its crew from the hazards of interstellar space, such as radiation and micrometeoroids, is paramount. The interstellar medium is filled with high-energy particles and cosmic rays that can pose significant risks to both the spacecraft and its inhabitants. Advanced shielding technologies, possibly using magnetic fields or novel materials, will be essential to protect the crew from these dangers. Developing life support systems capable of sustaining a crew for generations poses another significant challenge. These systems must be incredibly reliable and capable of recycling air, water, and waste efficiently. Any failure in these systems could be catastrophic, so redundancy and robustness are key. Additionally, the psychological well-being of the crew must be considered, as they will be living in a confined space for extended periods. The journey would necessitate a closed-loop system, recycling air, water, and waste to sustain life. This means that every drop of water and every breath of air must be reused and purified continuously. Advanced bioregenerative systems, possibly incorporating plants and algae, could play a crucial role in maintaining a balanced and sustainable environment. Despite these challenges, the human spirit of exploration thrives on pushing boundaries. Throughout history, humanity has always sought to explore the unknown, from crossing oceans to venturing into space. This drive to discover and expand our horizons is what fuels our efforts to overcome the obstacles of interstellar travel. The collaboration of scientists, engineers, and visionaries from around the world will be essential in making this dream a reality. By 2250, we may have overcome these obstacles, developing the technology and the resilience to embark on this extraordinary adventure. The journey to a binary star system will not only be a testament to our technological prowess, but also to our enduring spirit of curiosity and determination. As we stand on the brink of this new frontier, we are reminded that the greatest achievements often come from the most daunting challenges. Section 5: A Sky of Two Suns, Life in a New Light. Imagine standing on a planet where the sky is dominated by not one but two radiant suns. This binary star system creates a surreal and mesmerizing environment, unlike anything we have ever experienced on Earth. Life on a planet orbiting two suns would be a spectacle unlike anything we can imagine. The dual suns would create a dynamic and ever-changing sky, with light and shadows constantly shifting in a dance of celestial bodies. The interplay of light from two different sources would create a unique and breathtaking visual experience. The sky would be ablaze with two suns, casting shifting shadows and painting the landscape in a constantly changing palette of light and color. Imagine the hues of dawn and dusk, blending and merging in ways that are impossible on Earth. The colors would be more vibrant, the contrast more stark, and the overall effect a mesmerizing display of natural beauty. The day-night cycle would be unpredictable, with the length of day and night varying depending on the positions of the stars. Some days might be long and scorching, while others could be short and cool. The concept of time would be fluid, with the rhythm of life adapting to the ever-changing light conditions. This variability would challenge the inhabitants to develop unique ways to cope with the fluctuating environment. The flora and fauna on such a planet would be equally extraordinary. The plants might evolve to harness the energy from both suns, leading to a diverse and vibrant ecosystem. The dual light sources would drive the evolution of new and unique adaptations, resulting in a rich tapestry of life forms. Plants might evolve to photosynthesize different wavelengths of light emitted by the two suns, resulting in a kaleidoscope of colors. Some plants might even develop bioluminescent properties, glowing in the dark to attract pollinators or ward off predators. The interplay of light and life would create a stunning and otherworldly landscape, teeming with vibrant and unusual flora. Animals might develop unique adaptations to cope with the fluctuating temperatures and light levels, such as reflective skin or the ability to hibernate during periods of extreme heat. These adaptations would enable them to survive and thrive in an environment that is constantly changing. The diversity of life on this planet would be a testament to the resilience and adaptability of living organisms, showcasing the incredible ways in which life can evolve to meet the challenges of its